We are
live
from
TV.
Hi, today we're gonna solve limits analytically. This first example is the limit of radical 3x squared minus 5 as x approaches negative 2. So first things first is we're gonna plug in negative 2 to x. Here we get 3 times 4 minus 5. Then 3 times 4 equals 12 minus 5. This equals radical of 7, and this is your answer. The next problem is as the limit of 2x squared plus 5x minus 3 over x squared minus 9 as x approaches negative 3. Okay, so we're going to start by plugging in. However, we know that if you square negative 3, you get 9. So 9 minus 9 would be equal to 0. And we can't have a 0 on the bottom. That would make our function undefined. So instead of plugging in, we're going to factor. So first we're going to start by factoring the bottom, which we already know is going to be x minus 3, x plus 3. So the top, we are going to do the diamond. So it's going to be negative 6 over 5. We're going to have 6 and negative 1. So now we're going to bring the 2 to the bottom because it's still a constant and we still need to bring it down. So now we're going to divide the 2 to both factors. This cancels. This becomes x plus 3. And this becomes 2x minus 2, minus 1. And now, since we have the common factors on the top and bottom, we're going to cancel them. And now we're going to directly plug in negative 3 minus 1 over negative 3 minus 3. So now, we're going to have negative 6 minus 1 over negative 6. Negative 6 minus 1 is equal to negative 7 over negative 6. And then this is your answer.
Calculating a limit by multiplying by a conjugate. Example is limit of radical x plus 2 minus 3 over x minus 7 as x approaches 7. So if we were to plug in 7 on top, it would be radical of 7 plus 2, which would give you radical 9, and radical of 9 is 3 minus 3, and you get a 0. And if you plug it in the bottom, would be 7 minus 7, which would also give you 0, which we can't have that. So what we're going to do, we're going to multiply by the conjugate. When multiplying by the conjugate, your sign needs to change. So then it's going to be x plus 2 times negative 9 over x minus 7 times radical x plus 2 plus 3. So then when you add 9 and 2, it gives you limit of x, which is 7, x minus 7 over x minus 7 of radical x plus 2 plus 3. And as you can see, you can cross it out. Go. So then the limit as x approaches 7 is 1 over radical x plus 2 plus 3. And then we are going to plug in. So then it's 1 over radical 7 plus 2 plus 3 gives you 1 over radical 9 plus 3, and your radical 9 is 1 over 3 plus 3, and your answer is equal to 1 over 6. Special trig limits. The first example is limit of 5x over sine of x as x approaches 0. Formula that x over sine or sine over x, sine of x over x, they both equal to 1. So in order to get this to equal to 1, we are going to have to multiply top and bottom times 5. So then you would get 5 of x times 5 all over sine 5x, and this gives you 1, so it would be 1 times 5, and your answer is equal to 5.
Now we're moving on to graphical limits. Here we have a bunch of graphs and we're going to find the limits of them graphically. So at x equals a, there's a vertical asymptote, which means that the limit is undefined. So we're going to put does not exist right here. At x equals b, if we're approaching from the left side, we're going to get that f of b is at 1. But if we're approaching from the right side, we're getting that f of b is at 2. So the limit does not exist because they do not equal each other. But there is a value of f of b at x equals 1. At x equals 0, if we're approaching from the left side, we're approaching -2. And if we're approaching from the right side, we are approaching -2, which means that the limit as x approaches 0 is -2. But the value of f of 0 is 1. At x equals c, if we're approaching from the left side, we get that f of c is 1. And if we're approaching from the right side, we get that f of c is 0, which means that there is no limit because the right-hand limit and left-hand limit do not agree, which means it does not exist. On the other hand, this filled circle represents that the value of f of c is defined at -2.
The first problem is the limit of x as x approaches 0 of e to the 2x minus 1 over e to the x minus 1. To evaluate this limit, you can factor the numerator into two factors, like this. And since the numerator and the denominator shares a common factor, you could cancel those out. And you could plug in to get 2. I'm going to be doing another limit at 15, and it is the limit as x approaches -15 of x to the power 5 minus x over x to the power of 6 minus x. First, we notice that x to the power 5 minus x over x to the power of 6 minus x is asymptotic to x to the power of 5 over x to the power of 6, which is equal to 1 over x. And the limit of this is the same as the limit of this. So is then equal to 0.